Hello there and welcome to Pluralsight. My name is Tim Warner and this module is entitled Troubleshooting the Motherboard. Let's take a brief look at the learning path that we've developed for you here at Pluralsight to help you pass the CompTIA A+ 220901 certification exam. The learning path consists of 5 courses, the first of which is an introduction to the certification and essentially serves as a grounding before we take flight with the content itself. Hardware, networking, mobile devices, and troubleshooting all correspond to the content domains as published by CompTIA for the A+. You can download that blueprint by visiting comptia.org. Now let's take a brief look at the table of contents for this troubleshooting course. I wanted to take time in the first module to introduce you to the CompTIA troubleshooting model that we'll use throughout the rest of the course. Today we're studying the motherboard, and in subsequent modules, troubleshooting storage, display, network, mobile devices, and printers. We're essentially going around the proverbial horn, taking a look at each of the basic PC subsystems and computer subsystems, this time not from an anatomy and physiology standpoint. If you've been following this learning path sequentially, you've been there, done that, and bought the t-shirt. No, here we're concerned with troubleshooting SIC components. The overview is pretty straightforward here. We're going to look at a laundry list of common hardware and software symptoms, as well as their common points of resolution. At the end, we're going to review yet again some of the technician tools. If you feel that there's been some overlap or redundancy as we go through this learning path, you're not crazy, you're absolutely right. The reason why I think it's a good idea, though, is because as a CompTIA partner, we at Pluralsight are obligated to cover every single objective. And if you look at the blueprint for the A+, yes, you're going to see some overlap. And frankly, in the real world, in IT, you don't often get information handed to you in sequential manner. There is a lot of overlap in the IT tech's life. Let's get started. Meanwhile, in the real world, a couple questions that you're likely to see as working PC repair technicians. My computer takes too long to start up. Now you're probably thinking, well, Tim, that's about as generic as a complaint as possible. That's true. So it's our job as PC repair technicians to apply the CompTIA troubleshooting model and gather information. Let's say that we do that. We interview the customer and we learn that when they turn on the computer, when it first boots, it sits there for 30 seconds before it continues. So it just sort of idles for a while. That's useful information that we'll learn about in this module and we'll revisit at the end. Another question is, my gaming PC keeps shutting down. I'm hot and heavy in Mafia Wars or Destiny or whatever game it is, and all of a sudden the PC will just shut down. It's really causing me big problems here. Can you help? Of course, we can help, and we'll wrap this up at the end of the module. Our specific CompTIA A+ 220901 objective here is 4.1 that says, given a scenario, troubleshoot common problems related to motherboards, RAM, CPU, and power with appropriate tools. So we're not concerned just with the motherboard proper, but also those components that are directly connected to that motherboard. Common symptoms and resolutions. As I said, I'm going to give you a laundry list of a number of symptoms, all coming from the CompTIA blueprint, so you'll be very well prepared when you take your 901 exam to pass it. And this reminds me of a kata. If you've ever studied martial arts, some martial arts have sequences of moves. Yoga is another discipline where you sometimes will go through a sequence of poses. Here, I want you to be able to pivot when asked about any of these common symptoms and fire back the appropriate probable causes and resolutions. So starting at the top, unexpected shutdowns. So the user's just happily clicking along with their computer and it just turns off. What are some common causes and resolutions? Well, power supply overheating is going to be a common theme for many of these problems. Remember that the power supply is ultimately what powers the entire computer. And we have the ATX 24-pin connector and then individual component connectors that go elsewhere on the motherboard or maybe directly to devices like your video card and your hard drives and your optical drive. If the power supply is underpowered and you have too much hardware on the computer, then the power supply is going to shut off power as a fail-safe mechanism. Another possibility, and this is true especially if the user has has done DIY or do-it-yourself stuff is that perhaps he or she created an electrical short on the motherboard. Remember that screws are metal, so they're capable of carrying electrical current. Again, when the computer or if the motherboard senses that it's in trouble, it will just shut down as opposed to letting further damage happen. Now, I've also helped users with unexpected shutdowns without even opening the case. For instance, I remember at least one person I've helped who was kicking their computer. The computer was under their desk and they're just moving their feet back and forth, and they would eventually kick the computer case to the point where the power cable that was already loosely seated came out. So that was a very simple layer 1 problem. I informed the user what happened without using accusatory language, of course, and we moved the computer elsewhere so the user wouldn't kick it anymore. Reminds me of the old joke. The patient goes to the doctor and he says, "Doctor, my arm hurts when I move it." The doctor says, "Don't move it. I'll give you a bill." Anyway, let's proceed. How about system lockups? This is where the computer as a whole becomes non-responsive or freezes. That's a common end-user term, freezes. Now, this could just be a momentary issue with the application. The application is doing something CPU intensive, or it can point to a hardware problem. If you've recently updated the RAM of the computer, remember RAM has to be carefully selected and matched to your motherboard and motherboard feature set. RAM is a very big culprit for full system lockups where you actually have to shut off the computer to be able to continue with it. Another thing again is overheating. Like I said, you definitely want to become masters of the ATX power supply and always think to yourself, how does the power supply fit into this equation? Is the motherboard receiving too much power, too little power, and so forth? Remember that the power on self-test is what the computer does when it boots from a cold state. Not when it reboots, but when it's going from a power off state to on. The system BIOS will do a power on self-test where it checks directly connected hardware. It counts your RAM to make sure that it knows what's there. It looks at each of your system buses and so on. Well, each BIOS UEFI firmware manufacturer has a series of code beeps that correspond to different error conditions. Now, these error conditions would be linked to directly attached hardware like RAM, keyboard, MOBO. So if a user boots up and they hear beep, beep, and then the computer halts, it won't even load an operating system, then you're almost certainly facing a hardware issue and you want to research what those post codes mean, or those beep codes. RTFM, remember, means read the friendly manual. You want to make sure to understand. You'd look at the vendor of the computer, the vendor of the motherboard, what kind of UEFI BIOS you have, and that will lead you to a correct table. In fact, I want to show you one right now. As I said, you'll need a reference when you're troubleshooting startup post-error code beeps, and that those are specific to the firmware vendor. Here is a web reference. Check the course notes for all of these links. Don't be concerned with jotting them down right now. That's inefficient. But from one of the sites that I found, computerhope.com, it had a really nice summary of different vendors' BIOS beep codes. So on Dell systems, and you'll want to cross-check this with your manual, of course, but in general, if the BIOS ROM itself may be corrupted, that's just one beep, and then as you see, RAM not detected, motherboard failure. These are not happy messages, but it's better than nothing, of course. It's better than troubleshooting without having some help in this regard. Let's continue our trolley ride. We have 3 more situations, the first of which is blank screen on boot. The user verifies that the power lights on the computer are lit, but is the power light on the monitor lit? The monitor may be disconnected or just turned off. That's an easy, quick fix. Another problem, most likely, is that it's a resolution mismatch between the hardware capability of your monitor, the capability of the user's video card, and the capability of the device driver in the host operating system. How about BIOS time and setting resets? If you find that the computer's time and date keep resetting to something that's far in the past in all likelihood, and the post is taking longer because the machine has to redetect all of your hardware from scratch, that's a clear indication that the battery is dying or dead on the motherboard, and you'll want to replace it with a 2032 lithium-ion coin battery as soon as possible. Another possibility is that it's misconfigured, and by it I mean the BIOS UEFI settings. You may need to go in there and just to verify the settings and see if maybe a quote-unquote power user went in there to quote-unquote optimize their system, but instead wound up hosing things up. The good news is that most BIOS UEFIs allow you to reset to factory defaults, and that way you can start again. Another quick fix is when a PC attempts to boot to an incorrect device. There may be, again, a especially long pause at startup where it says DHCP ... and the user's just sitting here, what's going on? And maybe they'll get a no boot device found error. This is in all likelihood an incorrect BIOS boot order. Remember that the BIOS UEFI setup gives the user, the computer owner, the ability to adjust the priority of searching for boot devices from the USB, from the optical drive, from a particular hard drive, and so on. This is an easy fix because all we need to do is figure out the correct key combination to get into the BIOS setup and then adjust the boot order. That's a big payoff, and by big payoff I mean that the customer will be happy and relieved that they don't have to spend a lot of extra money buying hardware, and if they're at work, they'll be able to get back to work and resume productivity immediately. As far as correcting the BIOS, you know the deal with that. You're going to have to figure out, based on the hardware vendor and the firmware vendor, what the correct key combination is. Check the course notes. I give you some help in that regard. Once you're in BIOS UEFI setup, the user interface is going to be a little different. This is a true UEFI system where you have mouse support and network support and a really rich graphical user interface. But most BIOS UEFIs will have a page called Boot, where it will give you the ability to change the boot priority. In this case, it looks like you can specify whether network boot is enabled or disabled, and then what kind of storage devices can be booted from. In fact, there's even an option for PCI Express expansion devices. That's pretty cool. Older school BIOSes, like the one that I'm going to use in my demo today, give you a much more basic control over whether, say, to check the optical drive for a bootable disk before going to the hard drives. The other thing you can do in BIOS UEFI setup is to specify the post delay time. Now, ordinarily, when a computer posts, you just see the splash screen and it goes away within 2 seconds or so. When we're doing diagnostics, we might want to keep that initial screen up for longer. So if you can get into BIOS UEFI setup and there's a control like there is here with this ASUS firmware, we could adjust temporarily the delay time, maybe bring it up to 15 or 20 seconds. Just make sure to reset it back to the default so you don't force your user to sit there and wait extra time every time the computer boots. More common symptoms and resolutions. Are you tired of these yet? I hope not. I hope that you feel challenged by them. How about a system that continuously reboots? The user thinks that they've gotten into Windows, they think they're ready to go, and the machine automatically restarts. In most cases, though, in my experience, the reboot cycle happens before the user logs on. You want to check the power supply voltage level. I know I keep mentioning power supply over and over and over again, but it really underscores how crucial it is, making sure that the power supply has enough juice to power all the components of the system. You also want to pop the case and make sure that all of the power supply connectors are firmly seated in each interface. Another option, the most common one, is going to be a software/hardware conflict. Maybe you've replaced a network card or replaced a video card and you've incorrectly installed the wrong device driver. In that case, that mismatch can very well result in a reboot cycle, especially with a component as central as a video card. How about no power? Just no power at all. Let's assume, layer one, that the computer is plugged into an AC receptacle that is hot, that is live. You want to consider, is the power supply unplugged? Specifically, remember the ATX connectors on the motherboard. Those are going to be biggies. And you'll also want to look at connectors, Molex, PCIe, Berg, whatever, that are powering the other devices. SATA, of course, would be one on the motherboard. Another possibility, and this is a very scary possibility, is that the power supply is set for an incorrect voltage. Some power supplies allow you to use a hard switch to go from the 120 to 240, and you're going to absolutely fry your 120 volt system if you've set it for 240. So be very careful that the power supply is in fact localized to where the computer is physically located. Overheating is a generic symptom. How can you tell that the computer is overheating? Well, if you feel the case, especially true with laptop systems, it's very obvious. Sometimes you can smell the heat coming off the system as well. You want to check, are the fans working? If not, you want to take a look at the fans themselves, make sure that they're connected to the power supply, and you might want to make sure that the power supply is okay. It could be that the bearings in the fan have failed and the fan itself is a problem, and you can replace it. Another option, use compressed air and blow all of the dust bunnies out of the case. Make sure that the computer is properly ventilated. If a user keeps their computer on a thick shag carpet, that has its own set of problems with static electricity, but also that shag carpet can be blocking exhaust ports on the case and trapping heat inside the case. Not a good situation. Let's take a look at the next three now. Loud noise. Well, loud noise presupposes that you know what the normal noise level of the computer is. Especially mechanical hard drives, they sound like a gerbil running on an exercise wheel. That's how I've always described them. If you've inserted an optical drive, you might hear that spinning up. There's a lot of noises that are just simply normal. What you want to do is concentrate on abnormal noises. Perhaps one of your case fans is squeaky. You may want to remove it, WD-40 it, dry it off, put it back in. You may have a stuck optical disc. That makes a very horrible grinding noise. How about intermittent device failure? Sometimes the device works, sometimes it doesn't. I have a Jabra USB headset, and sometimes, even though it's plugged into a live USB port on my system, it doesn't get recognized. So I unplug and reconnect it, and it's fine. USB can be a little wonky like that. That's something that you can instruct a user to do himself or herself over the phone. Ask them to unplug the device, wait a minute, plug it back in. Of course, restarting the computer if it's a desktop system is always a possibility. Again, you want to also make sure that the USB bus on your system, or whatever bus is involved in the intermittent failure, has correct voltage applied to it. Speaking of power and voltage, this is an interesting case. The fans spin, but none of the other devices in the case are getting power, so you're not able to boot up. You press the power button, you hear the fans click on, but the computer just sits there. It's not doing anything. Well, what's that? That means that you've got power to some devices, in particular the fans, but you don't have power to the motherboard itself. Perhaps your ATX connector has come loose or just came unplugged. Admittedly, that's a little far-fetched. Those ATX connectors normally have a hinge, but just understand that it's possible to not have all the power available on the system if you have some plugged in, and in particular the ATX primary motherboard connector unplugged or poorly plugged. Associated with hard disks and that sort of thing, I'm just throwing in this slide here to reiterate that mechanical hard drives, by virtue of the fact that they are moving parts, you have your actuator arm and read-write head, and then you have a stack of metal platters. The read-write head is just a few microns off the surface of the disk. I mean, we're talking so close. And because of that proximity, if the computer gets kicked hard enough or tips over or experiences some kind of force, then it's possible for those heads to crash against each other and or with the read-write head. And if it's a severe enough head crash, it'll permanently damage the system. This picture shows a head crash that's so damaged, you can see the ring from where the read-write head is grinding into the surface of the disk platter. This is one of the many reasons why I'm not a fan of mechanical hard drives. When we have to use mechanical hard drives in servers, I believe in full redundancy, having entire arrays of disks that can be hot swapped and having data redundantly stored such that a head crash and a disk failure isn't catastrophic. Helping an end user who has a mechanical hard drive in their computer, you want to get them on a very rigorous backup plan to make sure that their end user data, all their pictures and documents and media, are stored in at least one other location, if not more than one, to ward against something catastrophic like a hard disk head crash. By the way, the sound of a mechanical hard drive that's had a head crash is pretty disconcerting. Like I said, normally a healthy mechanical hard drive makes a clicking noise. A hard drive that's had a head crash happen to it, it's more of a thunking noise. It's, like I said, very disturbing. Next, 3 common symptoms from CompTIA that we need to know. How about a problem with indicator lights? Well, remember that the front of the case has indicator lights for system power and generally for your hard disk and hard disk activity. You may just want to make sure to read the manual for your motherboard to figure out what red and what green and what yellow mean on those indicators. Could be blue, there's a few different colors. You also want to make sure that those indicator lights are correctly wired. Maybe they're not lighting up at all. Hopefully that's a layer 1 problem where you have an unplugged wire. Now, smoke and burning smell are both pretty top-tier problems that make it easy to troubleshoot, although I shouldn't say that because it's not always easy to troubleshoot. If you actually have visible smoke on the computer, then dollars to donuts, you've got a catastrophic failure with the power supply and or capacitors. Capacitors are electrical components that are essentially mini batteries. They're used to store charge. So because of that, they're prone for explosion, really. A catastrophic capacitor failure or power supply failure can result in overheating to the point of smoke. That's a reminder that as a PC technician, you should always have use of or have possession of a Class C fire extinguisher. Fire extinguishers have various classes depending upon the types of fires that they're designed to combat. Class C is what you want to remember for electrical fires. Burning smell, again, is probably a failure in the power supply and or capacitors. You want to do the sniff test and get accustomed to what burning electrical components smell like. That's not something you want to smell in anything outside of a lab environment, but you need to know that not all burns are visible. You may smell burning even though you don't see smoke or any obvious burning on the motherboard. Now, as far as repairing this kind of problem, boy, this can be a real big issue depending upon how the damage has spread on the motherboard. If it's a blown capacitor, in fact, I have a picture that I'm going to show you in just a second, you may or may not want to attempt replacing that component yourself. First of all, electrostatic discharge. We've covered this earlier in the course, in the hardware course, but remember that ESD refers to the transfer of electrical voltage, not through a circuit, but directly from object to object. And I mentioned that electrical microelectric components like you find on your motherboard can be damaged by levels of voltage that you can't even feel. So this underscores how crucial it is for you to ground yourself whenever you're working with your computer and troubleshooting, upgrading, or otherwise. These are I believe they're scanning electron micrographs of microelectric components that show actual crater damage from ESD. You wouldn't be able to see this damage with the naked eye, but if you can put the components under a powerful microscope, you can see that we have at the left an actual pit, and at right it looks like just literal burn marks, scorch marks on those components, and they can spread from one component to another, rendering entire sections of your motherboard really destroyed. The ESD reminds me of lightning damage. If you've ever seen damage of honest-to-goodness lightning, it can splinter trees right down the middle. ESD is a very similar dynamic, but on a much smaller scale. The other thing is the distended capacitor. Distension refers to puffing out. So as you see, these capacitors are likely to explode. It looks like some sort of problem has happened inside the units to make them bulge out. That's not a good situation to see. And like I said, I've never attempted and would never attempt to replace an individual capacitor on a motherboard. I know people who are good enough with electronics to do that, but I personally wouldn't recommend it. I would suggest you try for a warranty motherboard replacement because this is definitely a manufacturer's error in most cases. We have 2 final symptoms: proprietary crash screens and distended capacitors. Well, we've already done the distended capacitors, so let's focus on the proprietary crash screens. If your system displays one of these things, normally there's a timeout period. Depending upon how the operating system is configured, there may be what's called a RAM or kernel dump, where all the contents of memory get written to disk. That can be useful for advanced troubleshooting purposes, but I found that, again, device drivers and conflicts with newly installed hardware often is the result of this. Sometimes it's a bug in the operating system, but like I said, you'll probably find that if you get persistent crash screens, maybe the user has upgraded RAM recently. I had a situation with a customer not too long ago, and this customer went really to good lengths to ensure that the RAM she was buying was compatible with her computer, but it turns out it wasn't the correct RAM after all, and when we got her the right RAM, no more crash screens. Oftentimes these crash screens will display error codes, stop codes. They have different names. Oftentimes memory addresses that are in hexadecimal. You want to take a capture of that screen. Whip out your cell phone, take a picture of the whole screen, and that way you can perform research online specifically referencing those codes. As I said, distended capacitors can be either a manufacturer's defect on the motherboard or it could be a failure in the power supply. I want to show you some proprietary crash screens. In Windows Server 2008 and Windows XP and earlier, when a computer crashed, when the OS crashed, you'd get the BSOD, the blue screen of death. And you see a whole bunch of wonky hexadecimal values. The main stop code is on the third line here. In this example, IRQL, not less or equal. That's mostly due to drivers, like I said. You're going to want to take a screenshot with your camera, like I said earlier, so you can research the problem. Nowadays, in Windows 8.1, Windows 10, Windows Server 2012 land, Microsoft has replaced the blue screen of death with a much more user-friendly display. You get an emoticon, and they give you a user-friendly response, and then it says, if you'd like to know more. I know the text is too small for you to read. The bottom line says, if you'd like to know more, you can search online later for this error. Now, I personally, as a technician, don't like this. I would prefer the true blue screen of death because the more information you get regarding a crash, the better. That's my own opinion. In the Apple world, in Apple OS X, if you have what's called a kernel panic, that's what Apple calls a full-on system crash, you get the entire screen goes dark and you see this. Notice that it's localized in 4 languages. In English, it says you need to restart your computer, hold down the power button for several seconds, or press restart. I mean, it's nice that it's localized in common world languages, but I don't like the fact that by default you get no information. That having been said, once OS X reboots, you will get a screen that has diagnostic information. So that is true, and I have benefited from that in my own work as a tech. Linux as a geeky operating system, even Ubuntu and OSs that try to be as user-friendly as possible, when they kernel panic or crash, you'll just get a screen that has a bunch of what appears to be gibberish. Again, you'll definitely want to take a clear picture of it for later analysis. Technician tools. A lot of this is review. Remember that the multimeter is used to analyze AC and DC circuits. You want to match up the red and black leads. If you're testing a power supply, red probe on the multimeter goes with a red wire in the power supply, black goes with black. And we measure the basic quantities of an electrical circuit: resistance, current, and voltage. Once you've figured out reds and blacks with your leads, you can use the dial to determine whether you're looking at resistance that's measured in ohms, voltage that is in volts, and current that is measured in amperes, or A. Notice that the current and the voltage have separate icons that are pretty much industry standard. Direct current has the straight lines and alternating current has the wavy. And finally, let's say we're testing a power supply for voltage. You'll want to set the dial to the appropriate range. Notice that there's 200 millivolts, 2 volts. For computers, you'll probably want to do 20 or 200. It's okay to go high on your range. It's not okay to go too low. The power supply tester, again, I've showed you this several times. The small portable ones provide a nice way to do a sanity check on your ATX power supplies. If you're part of a larger repair shop, you may have a dedicated appliance, something like this, that makes it easier to plug in and plug out multiple power supplies. Sometimes you can operate on multiple power supplies at once. The loopback plug, again, we've talked about a lot. Common situation is, as a network tech, you may need to free up a switch port. You've got a switch that's just totally occupied with RJs, and because the customer hasn't documented their network, they can't tell you which of those are live connections and which aren't. Admittedly, you can look on the switch itself for a link light. But the loopback plug, one of its many uses, is that you can unplug a cable from the switch. Now understand that's going to be a last-ditch effort because you could be unplugging a server or a user's computer. Sometimes, though, desperate times call for desperate measures. Unplug the cable from the switch into the RJ45 port of the loopback, and if the loopback LED lights up, you know that that is a live connection and not a dead one. The postcard. Remember the power on self-test? We talked about that earlier. Postcards are useful for diagnostics, especially when you're building a computer. I've found in my experience in years past, it seems you almost have to build up the entire device before you can test whether the system boots. That is to say, have RAM installed, your video card online, blah, blah, blah. With a postcard, these, and it's kind of funny, postcard, yeah, it's not something you send through the mail. Notice that they have several inputs. There's USB, PCIe, sometimes parallel, so I've used them with plugging in the postcard directly into a PCI Express or an old school PCI slot, and you can test the motherboard without having all the other components installed. So you power on the system and you can at least get a post code, a non-error state post code. That is, you won't get like keyboard unplugged error or something that's expected. If you get a post error, it will be something genuinely useful. These post codes, remember, are specific to different firmwares, and these postcards come in different form factors. This is a true USB interface one. Full-size USB on one side and what looks to be a micro USB on the other. Final thing I'll say is that these postcards can be especially handy in terms of offering other functionalities. Some postcards actually can test your memory, for instance, do a hardware memory test in addition to just looking at post. In our demonstration, I'm just going to quickly buzz through some various motherboard-related troubleshooting steps. This is one of many sites that you can find to look up computer post and beep codes. You see this one has award, all the major BIOS UEFI manufacturers, but you'll want to cross-check those if you see any conflicts with your hardware that you're working on, because this could be outdated. It depends. As far as troubleshooting stop or kernel panics, depending upon the operating system, they call it different things, you'll just simply do a Google search and develop your Google foo. It's as simple as that. This is a screenshot from a piece of software Microsoft has called the Desktop Optimization Pack. It's called MDOP. Now, you have to be licensed for it. They don't sell this directly to consumers, but assuming that you're part of an enterprise that has an enterprise licensing agreement with Microsoft, you can get it. It's a suite of really useful tools. We don't have time to talk about anything but the one I'm highlighting now, the Diagnostics and Recovery Toolset. It can be useful for many reasons to boot a system off the hard drive. In other words, the installed hard drives, the boot media is offline, and you're booting from a USB thumb drive or a DVD that contains diagnostics tools. I showed you Hiron's in the previous module, but that has questionable legality. The Microsoft Dart toolset is intended for Windows systems and can troubleshoot or help you troubleshoot a lot of the errors that we discussed in this module. I'm going to show you it very briefly. And by doing that, I'm going to boot a virtual machine here that I have that's called DC, that runs Windows Server 2012 R2. I'm going to edit its settings and verify that I have the MDOP ISO image mounted, which I do. And a neat thing that you can do with virtual machines is instead of having to worry about a key combination, you can do a direct power on to firmware. So I'm going to boot directly into System BIOS here. This is a very basic Phoenix BIOS, and I just want to show you that on the boot page we can use our plus and minus keys on the keyboard to adjust the order in which devices are probed for boot media. So if I wanted to boot this system from CD, which I actually do, I'm going to need to adjust the order. So let me move hard drive to below CD drive, and we'll want to go to exit and save our changes. Now, we could also change other options like BIOS boot delay depending upon the firmware. So let's restart this virtual machine, and it's going to jump directly into the Dart recovery environment because I've created the Dart DVD and linked it to the virtual machine. Excuse the wonky resolution here. The virtual machine is defaulting to 640 by 480. We're asked if we want to initialize network connectivity. Boy, this can be useful when we're diagnosing a malware-infected system for sure. Because Dart uses the Windows pre-installation environment, also called Windows PE, we can get to things like a graphical interface, the mouse, the network. There was a time when we didn't take that for granted. And ultimately, we see this Diagnostics and Recovery Toolset window, and we have direct access to some really awesome utilities here. Very common administrative quick fixes. If you're in a desperate situation and the time is of the essence here, you may just want to be able to boot from outside the hard drive and use Explorer here to get to the file system and copy off as many of the user's files as possible before the hardware really dies for certain. You'll notice that there's a crash analyzer here that enables us to dip into dump files that were created as a result of a blue screen of death and to perform a more structured analysis of them. In short, I just want you to know that the Microsoft Diagnostics and Recovery Toolset is another tool that you may want to add to your PC Technician software toolkit. Now back to the real world, let's revisit those two questions. Remember, the first was, my computer takes too long to start up. Well, in the name of quick fixes, perhaps it's just as easy as a BIOS boot delay that we can fix by booting into setup, changing or disabling the delay in the user's set. With regard to the gaming PC that keeps shutting down, you know what I'm thinking with that one, right? Yes, the chances are good that because the user's a gamer, they have a super high powerful, maybe an SLI video card, and the power supply just can't keep up. Check the power supply and make sure that its wattage supports that of the components in the gamer's system. For homework, I'd like you to procure a junker PC. By junker, I mean some PC that may be old enough to where the user doesn't care about it anymore and gives it to you. You can find them at yard sales sometimes, or check Craigslist. You have the whole notion of people giving stuff away for free as a lifestyle. I forgot what that's called. There's a term for that. But anyway, once you bring the junker PC home, I want you to use your tools, both your conceptual knowledge tools in your head, as well as any hardware and software tools that you have in your disposal, to figure out what exactly is wrong with the computer. Maybe you'll find that there's a lot right with it. For further learning, check out Mike Halsey's course on Technology Troubleshooting Fundamentals. The whole course is worth your time as a PC repair technician, in my humble opinion. Also, Jason Alba's course, Customer Service for Software Developers, Delighting Customers. I submit to you that everything he talks about there, even though his primary audience is the software developer, we IT pros need those customer service skills just as much. In summary, we didn't talk about warranties too much specifically, but warranties are great things. I'm talking about manufacturer's warranties on your computer, motherboard, and associated components when it comes to these issues, because you may not have to do anything but submit a warranty replacement request instead of having to go and get your hands dirty and potentially make a problem worse. That's a worst case scenario, of course. I hope I've also underlined the fact that we often need hardware tools to be able to visualize what's happening in those complex electrical circuits in a system. Now, in the next module, we're going to drill in on troubleshooting the display subsystem specifically. I look forward to seeing you there. Thanks a lot for your participation. Have a great day or night, wherever you are in the world.